This is question 10, getting towards the end of the paper now. Below we've got what's called a karyotype, which is a picture of each individual chromosome you'd find in a diploid cell. This person has a rare condition that affects their chromosomes. Okay. First question, how many chromosomes are shown in this image? Remarkable that not everyone didn't get this mark here. You're simply counting 1, 2, 3, 4, 5, 6, all the way down to 47. So here, this would be 44, 45, 46, 47. Kick yourself again if you didn't get the simple mark there. Next one, state the sex of the person the chromosomes were taken from. A little bit difficult, a little bit different from what we've seen. Most of you should know that XY equals male. Okay. This one's XYY, which is unusual. But if we think about the normal situation, only men have the Y chromosome. Women don't have or females don't have a Y chromosome. Therefore, this one would have to be male, even though it's got 2 Y chromosomes, which is slightly unusual. We'll talk about that in a second. But the fact that it's got a Y chromosome would make it male. Describe how the chromosomes in the photograph differ from those found in a human, normal human body cell. Well, a normal human body cell would have 46, so we know this one's got 47, so it's got an extra or additional chromosome. And in this scenario, that extra chromosome is actually, in fact, it has 2 Y chromosomes. You could, in fact, get the mark for stating, how is it different? It says it has an extra Y chromosome. Okay. C, this rare condition leads to the formation of abnormal sperm cells. Name the type of cell division that produces sperm cells. You should know that from when we covered it. Mitosis is when you make identical copies of cells. That's for repair and growth. Meiosis is the cell division in which you halve the chromosome number, you produce all gametes. It's important that chromosome number gets halved before sexual reproduction, so that 2 halves in those gametes can fuse to become a new whole, a new individual. Last question is quite difficult, and again, we notice that the command word for these difficult questions, once again, is that suggest. When we see suggest, we know it's going to be quite a difficult question. So, suggest how an individual of these chromosomes could have been produced. Well, I'm going to tell you what's happened first and what the marks are, and then maybe try and explain it a little bit different. What we could suppose has happened here is that at some point during cell division, some point during that meiosis process, is that chromosomes failed to separate properly. That means that the sperm has ended up with 2 Y chromosomes and then what's then happened is that abnormal sperm with the 2 Y chromosomes has gone on to fertilize an egg cell. So that's what we're stating what's happened. Let me try and explain that a little bit now. So if we remember in meiosis, just kind of quickly, let's just draw a cell here. What do we mean by this? Well, meiosis has 2 rounds of cell division. We know that. Let's make our pen black. So in those 2 rounds of cell division, what happens is, if we imagine we're just looking at the sex chromosomes, so if we take a man to begin with, they would have, male would be XY, I got a bit wrong there. So what would normally happen is you would have, at the beginning, you would have each chromosome copying itself. That would be the X, okay? And you would have the Y chromosome aligning this side of that cell. So first round of cell division, that splits in two. So they end up with one sperm up here that would have an X chromosome, but with two sister chromatids, whereas we'd have the other one ending up with the Y as two sister chromatids. Normally then what would go on to happen is that those two X chromatids would be separated, so that what would happen is you'd end up with each of these sperm cells having an X, and normally what we'd expect to happen is that Y going on there. What we can assume has happened in this scenario is that instead of that Y, that pair of Ys, let's just bring them back again. So instead of that Y separating properly, for some reason, the cell has split here. And what it's gone to produce is one cell that's got no sex chromosome in it. That would be unviable. It wouldn't lead to a kind of a successfully fertilized zygote. It wouldn't work. But the other sperm cell has ended up with two copies of that Y chromosome because it didn't split apart properly there. If this sperm were to then go on and be fertilized by an egg that had the X chromosome, when they fertilize together, you can end up with potentially that zygote with an X, Y, Y, like we see in the picture up there. So that's what the question's talking about when we say the chromosomes fail to separate. It means that the sperms end up with two Y chromosomes, and the normal sperm has then gone on to fertilize an egg cell.